Hello everyone. Welcome to lesson 9.6. You're going to be able to find the area of composite figures. Now this is one of my most favorite lessons I prepared. I don't know, I think it's a lot of fun. You might disagree with me, but it's kind of like, fun. Alright, so what is a composite figure? Composite figure, a shape that can be divided into more than one basic shape. For example, I have this is a trapezoid right here, all right? But I could also turn it into a square and a triangle. So, for instance, if I didn't know how to find an area of this trapezoidal figure, I could find the area of this square and then find the area of the triangle and add them together. Okay, so there's going to be figures you come in contact with or see that you might not have a formula to find the area, but you know the formula for other areas, so you can combine them, and that's why I think it's a lot of fun. Okay, so let's find the area of this figure. It's my house. All right, now when you look at this thing, let's take a look together here. When you look at this, what do we see? I see a rectangle and a triangle, all right, because there's no formula for finding the area of this house that I know of, at least right now. So I have to find the area of two separate figures and add them up. So I see a triangle right here, and then I see the rectangle right below it. Okay, so there's my two figures. So let's start off with rectangle because it's already set for us. The area of a rectangle is base times height. So I have 10 times 6 equals 60, 60 inches squared. So this figure is 60 inches squared. And I'll keep that right in there. Now my triangle, let's see. Who remembers what the area of a triangle is? You're right. It's base times height divided by 2, or half base times height. So I'm going to write that up here. Base times height divided by 2. Okay. So I have my height here of 4, and my base, let's see. There's no base right there. But I do know this. This is the fun part. It's kind of like, I don't know, where's Waldo or doing a puzzle. I have 10 inches across this base. So this whole base must be 10 inches. But as you can see, I have a clue here that of this line, of this 10 inches, 6 of those inches go right to here. All right, so 10, 6 plus what equals 10? Because this whole line should be 10 inches, because this whole line is 10 inches. 6 plus 4. So this part is 6, and my base of my triangle is 4. So my base is 4, my height is 4, and then I'm going to divide it by 2. 4 times 4 is 16, divided by 2 equals 8. So my area of this triangle is 8 inches. Now, so what is the total? Now, the picture is kind of, I don't know, doesn't look right. This whole thing is 60 and that's only 8, but that's what the numbers gave me. Okay, so what's my total area of this figure? What is 60 plus 8? 68. So this figure has an area of 68 inches squared because it is 2 dimensions. That was a lot of fun. If you had a lot of fun, give yourself a smile right now. I really enjoyed myself with that one. Okay, how about this one? You tell me, what do you see here? What do we see? I can do another triangle and rectangle, but I'm going to make my life a little bit harder and deal with trapezoids, I think. I have a trapezoid right here if I draw my line that way. So I have a rectangle and a trapezoid. Maybe I might mess this up, I don't know. I didn't do this ahead of time, so I'm doing this for the first time. And I like to try a trapezoid since we did triangle last time. Let's start off with the area of our rectangle here. Now rectangles are parallelograms, and the area equals base times height. Okay, so I have a base of not 12, because this whole length is 12 right here, but I have a clue up there that my base is 8. So this piece is 8. And before I go ahead, if this piece is 8, 12 minus 8 equals 4, so this piece from here to there is 4. So I'm going to keep that in mind. So this base is 8, my height is 4. So my area of that rectangle would be 8 times 4. And of course that is 32. Alright, so this area is 32 feet squared. That's good. That's all good. Alright, now I have to find the area of this trapezoid. Before I go on, I need to remember I need base times height. Nope, that's not it. That is not it. Area of a trapezoid equals height times base 1 plus base 2 divided by 2. There's my area of a trapezoid. Okay, so it looks like I have a base over here of 10 feet. So I'm going to plug that in. My first base is 10. My other base, oh, I guess I do know. It must be 4 feet because this line is the same as this line. So my one base is 10 feet, my other base is 4 feet. So I'm plugging it right into my formula. Alright, now I need a height. And I already found that out earlier. Alright, because remember, this whole thing is 12 feet, but this part is 8 feet, and 12 minus 8 equals 4. So this is my height. I'm turned around, but that is my height of 4 feet. So now I can find the area of that trapezoid. I have 10 plus 4, which equals 14. Now I'm going to do 14 times 4. Let's do that in our head. 10 times 4 is 40. 4 times 4 is 16. So 40 and 16 make 56. All right. And I'm left with 56 divided by 2. Let's do that one out, even though I know we could do it in our heads. How many times could 2 go into 56? Twice. 2 times 2 is 4. I get 1. Bring down the 6, 16. 2 goes in 16 8 times. So the area of this trapezoid is 28 feet squared. I'm still not done. The total area would be 32 plus 28. 32 plus 28, and I get 10, and then 6, and I get 60. This whole area of this lovely figure is 60 feet squared. I know it's a lot of work. You might have to rewind it to, see what I did there, but I had a lot of fun. It takes a while to do one problem. You have to really slow yourself down and look at this figure and figure it out. All right, so moving on. We have one other thing to teach today. I'm not going to focus on it so much. I'm only going to give you one example, but this is also pretty cool. Let's find the area of overlapping figures. So it's essentially asking, what is the area of the outside of these two figures? Okay? What is this area? Now there's a little square in between there, and that's going to be very important. All right, so this is quite a bit of work, so buckle up. Let's see what we have to do. All right, I'm going to find the area of both figures, right? But since they overlap, I'm going to have to cut out this piece. I'm going to have to cut out whatever that is. So I find the area of this piece, find the area of this rectangle, and cut out where they meet in the middle. So the first one is base times height, which is 12 times 12. And if you don't know that by now, it's 144 centimeters squared. All right, over here I have 15 times 12. We'll do that one out. I know the answer, but I like to do it out sometimes. 2 times 5 is 10. 2 times 1 is 2, plus 1 equals 3. And x minus 0. 1 times 5 is 5. 1 times 1 is 1. And I get 180. So I have 144 and 180. So I'm going to add those together right now. And I get 4, 12, 324 centimeters squared. Okay? Now, that would be my area of these combined figures if they weren't touching. Like if I pulled them apart, that would be the area. But now I have to take that 324 centimeters and subtract whatever this area is in there. Now here's the fun part, if you weren't having fun yet. We have to find the different dimensions, our base and height. Okay, there's no base here, there's no height there. Well, let's see. What can I do? Well, I know that this line is 15 centimeters across. So that must mean this line is 15 centimeters across. But of those 15, 8 of them are right there. And 15 minus 8 equals 7. So this piece of the line is 7, and that piece of the line is 8. 7 plus 8 equals 15. But I don't need to know that for this middle square. I just need to know that my base is 7. Both of those sides are 7. Okay. Now I need to find the height. So, what can I do here? What can I do? Ooh, I see. This whole line right here is 12 centimeters. Of those 12 centimeters, 6 of them are right here. So what plus 6 equals 12? Well, it's 6. So this whole line equals 12. I have 6 there, and then 6 there. So now I have my base and my height. And to find the area of this parallelogram or square, or it's not a square, or a rectangle, is 7 times 6. And let's do it. 7, 14, 21, 28, 35, and you guessed it, 42. So this figure is 42 centimeters squared. So now I have my 324. All I have to do is minus my 42. Here we go. 4 minus 2 is 2. 2 minus 4 I have to borrow. I get 12 minus 4, which equals 8. And 2 minus nothing is 2. The area, can we still see it over here, is 282 centimeters squared. That was a lot of work for one problem, but I think it's a lot of fun. You know, we can take our time. We don't need to rush. All right, if you're confused on everything, we'll definitely go over tomorrow. But give these questions a try. I would like for you to find the area of this figure. If you can't see it, let's zoom in a little bit, and I'll read off the numbers just in case. This is right from your book, too. One of the pages in there. I'm not sure of the page. All right, so here are dimensions of this whole thing. Looks like, how many sides? 1, 2, 3, 4, 5, 6. So it's sort of like a hexagon here. We have the entire base down here of 36. That says 36. We have a height right here. That says 20. So if you need to rewrite these because it's blurry or your computer screen's too small, we have 20. From here to there, there's a dotted line. We have 10 feet. From the base to up here, we have 14 feet. If you can't see that, that says 14. This piece is 20 feet, and it says the 14 again over here. All right, those are the dimensions you have. What can you turn this into? You can turn it into a couple shapes. I see a trapezoid over there. I see another trapezoid over here, then a rectangle. It's up to you. All right, take your time, figure it out. And the other one we could do is going to be a lot easier to see, I believe. This is also in your book. All right, find the area of this figure. We have dimensions of 10, 7, 7, and 5. What can you guys do to make this into two figures? I see something right there. All right, so good luck with those problems, and I will see you when I see you.